Long ago, in the land of Singapore, legend tells of an all-powerful ring created by the evil Lord Sauron to rule over all mankind. Lost for centuries, the ring now finds its way into the hands of the most unlikely person of all.
The ring must be destroyed. You must head to the labyrinth of darkness, explore the maze while avoiding obstacles, and then head to the end of the labyrinth as soon as possible.
I cannot do this alone.
The fellowship consisted of 4 races: the hardware dwarfs, the Nexus elves, the Arpai messenger, and the Algo wizard. And so their journey began.
We have a total of 6 sensors used, 1 for the left side, 3 for the front, and 2 for the right side. Our robot is able to cover and detect the front part using 3 front sensors. The middle right side one is to tune and align the robot. For sensor calibration, we choose to take multiple readings each time and get a median of these readings in order to avoid receiving spikes.
Instead of separate left and right PID, I use something like X and W angle PID. So if we want to go straight, we just set the W to 0 because W is the angle that the robot wants to tilt, and X will be the distance that we want to travel. So that's how our PID works.
Even though PID was quite accurate, there were still some small errors. To overcome this, our team successfully implemented a stable tuning algorithm. The tuning algorithm consisted of 2 parts. The first part ensures a fixed distance from a wall, while the second part ensures that the robot remains parallel to the wall. For distance tuning, the robot turns to the wall, aligns, and then moves back to the fixed distance. During the angle tune, the robot turns to one side and then slowly turns back while measuring the distance from the wall. Once it finds out that it has crossed the minimum distance, it stops, thus becoming parallel to the wall again.
For our algorithm, our map is using 5 cm by 5 cm grids to set a 5 cm safety distance and increase the mapping accuracy.
For exploration, we use a right wall follower algorithm, which sets the bot to move around in an anti-clockwise manner. We then export to a spiral technique, which is wall following but marking the visited nodes, and then a wall follower with fake obstacles so that the bot will go into the middle.
The optimal path is implemented based on the Digestrous algorithm with modifications to incorporate turning time as costs.
The objective of the Android team is to provide visual status and remote interaction with the robot. The application will connect to Raspberry Pi through the Bluetooth interface and interact with the robot through on-screen buttons and receive status updates for the robot through text messages and a visual map. As the team faces the need to adapt to changing requirements, they have thus made all the buttons reconfigurable.
The Raspberry Pi is one of the major components that was reside in the center of our system. Its responsibility is to receive, coordinates and send information between PCs, Nexus 7s and Arduino. The receiving and sending part was done using Wi-Fi, Bluetooth and serial cable. However, before using it, the Raspberry Pi is required to be configured. As for the coordination, a static routing table was implemented, so that only the specific information will be direct to the correct destinations and the invalid information will be discarded. In addition, the Raspberry Pi must also support reliable connection between all connecting devices, so that during the actual run, if one of the connected devices fails, it will also able to reconnect back and proceed what it was left off.
During integration phase, we have some connectivity issues such as intermittent disconnect, data send was incorrect, and etc. However, through research and testing, we managed to get the RPi to communicate among all the connected devices. However, problem does not stop here. Instructions received by Arduino for running shortest path became out of order. This could be the race condition occurred on Raspberry Pi side. In order to solve this problem, we let PC send instructions in a one string to RPi. RPi pass the string to Arduino. On Arduino side, we implement a buffer to hold the string of instructions and then execute the instructions one by one.
And finally, after weeks of hard work and determination, the quest was completed, the ring destroyed and Sauron defeated.